destiny had other plans for young Madhava. When he approached his mother for her blessings, she reminded him of his duty to his motherland and his fellow people. You must search things where they have fallen. You must earn in your own land. With these words as his war cry, Tonsei Madhava Anand Pai set out to achieve what many would call impossible. The seed of Manipal was thus sown. A journey of 1,000 miles begins with a single step. Walking together with countless miles. It all began in the gleam of a great man's eye. In the light of his inner soul, he believed that this was his ultimate goal. It's my life, it's my life. Oh, the sky is not the limit, 'cause there are footprints on the moon. It's my life. His infectious zeal propelled him to serve his own people, and he set a goal of transforming, empowering, and nurturing lives through education, healthcare, and banking, the most basic aspects of social upliftment. High schools in every village, small-scale industries like dyeing and weaving, sawmills that provided employment, institutes of higher education, rural banking. There was no area that he left untouched. Along with his brother, he started syndicate banking with a motto: no man is too small for our land.
Syndicate Bank, that was a new philosophy. It is a small man that ultimately contributes to the greatness of the institution. There must be an institution like a small savings to the people, one with millions in our touch.
He even started a Hindu orphanage during the days of our freedom struggle, as many children were being orphaned due to the dismal life expectancy of just 27 years. He brought sheer joy to the lives of the underprivileged. His relentless efforts transformed the barren land of Manipal to the exciting Manipal University Township. Dr. T.M.A. Pai was passionately driven. He even said all that he was doing was not work, but fulfilling the vision of the Almighty to serve the needy. His sense of social responsibility was complete. He had a belief that the common man had a lot of common sense, and if channeled into productive work, he can be made beneficial to man and society. His idea of vocational training leading to employment was a far-fetched idea. But Dr. Pai was thinking out of the box, ahead of his times. Just like the idea of starting India's first private, self-financing medical college at a time when the country badly needed professionally qualified doctors. Kasturba Medical College, established in 1953, provided equal opportunities for all to study medicine. The Manipal Institute of Technology took birth in 1957, followed by a string of other institutions.
I have been traveling with him in the study of so many high schools and colleges. And it was a great experience for me. He was a practicality. He didn't want everything to be done by the government. And he used to go forward taking along with him his followers and friends.
Featured in Ripley's Believe It or Not, for establishing the maximum number of institutions in one lifetime, TMA was a man of values, uncompromising in his integrity and honesty of word, deed, and purpose. One of the biggest reasons for his success was his availability to all. His simplicity, friendliness, and sympathy for those in distress. He has set the path of social responsibility on which we are continuing our journey.
To me, it's the most beautiful thing we have done. We never thought that there was a failure. The word failure did not occur in history. Here is a man that God had perfected. And I always keep saying, the moment he told his mother, life to Amma, even so came mother, Manipal was born.
Today, as we carry forward the mantle of his vision and values, we remind ourselves that life itself was his continued inspiration.
A very good morning to one and all present here. I'm Alan,
And I'm Iona.
and we will be your MCs for the day.
We would like to extend a warm welcome to all the dignitaries, the freshers, the parents, and our dear professors to
Rejuvenate 2023. The Orientation Day program of Manipal Institute of Regenerative Medicine, Bangalore.
So, Alan, it's been quite some time, right? Just a few years ago, we were right at the same place our freshers are in.
Yes, Iona, it's quite nostalgic indeed. Right from our schooling to bachelors, here we've reached a point to search and to quench our insatiable thirst for science.
Yep, big time nerds for sure.
We, our MCs, are proud alumni of the same institute.
Fun fact, today was the same day we started our journey in the year 2019.
From classmates,
Two lab mates.
we continue our journey in the PhD program at MIRM. And so to our juniors, should I say super juniors, welcome aboard.
Today, you all have gathered here from various fields such as biotechnology, microbiology, pharmacy, MBBS, dentistry, engineering, and even nursing to be part of such an interdisciplinary program such as this one.
So without further ado, let's carry on with our program for the day.
As part of the Manipal community, where technology and cultural aspects go hand in hand, we now invite our second year MSc students, Miss Ahana Das, who will be performing to the vocals of Miss Lauren Susan Soni.
Over to you guys.
Check, check, check. महागणपतिं मनसा स्मरामि महागणपतिं मनसा स्मरामि महागणपतिं मनसा स्मरामि महागणपतिं मनसा स्मरामि वसिष्ठवामदेवादिवन्दित महागणपतिं मनसा स्मरामि वसिष्ठवामदेवादिवन्दित महागणपतिम् महादेवसुतम् महादेवसुतं कुरु कुहनोकं महादेवसुतं कुरु कुहनोकं मारकोटि प्रकाशं शान्तं महादेवसुतं कुरु कुहनोकं मारकोटि प्रकाशं शान्तं महाकाव्यनाटकाधिप्रियम् महाकाव्यनाटकाधिप्रियम् जटाटवीकलज्जलप्रवाहपावितस्थले कलेवलम्ब्यलम्बितं भुजङ्गतुङ्गमालिकां ठमट्ठमट्ठमट्ठमानिनाटवट्यमर्पय चकारचण्डताण्डवं तनोतना शिवा शिवम् जटाकटाह सम्भ्रमा भ्रमण्निलिम्बनिर्जरि विलोलवीचिवल्लरी विराजमानमूर्धनि ठगट्ठगट्ठगज्ज्वलाललत्तपट्टपावके किशोरचन्द्रशेखरि रतिप्रतिक्षणं मम धराधरेन्द्रनन्दिनी विलासबन्धुबन्धुर स्वरन्धिकण्डसन्ददि प्रमोदमानमानसे कृपाकटाक्षधोरणी निरुद्धदुर्धरापडि क्वचिद्दिगम्बरे मनो विनोदमेतु वस्तुनि छटापुजङ्गपिङ्गलस्फुरत्पणमणिप्रभा कदम्बकुङ्कुमाद्रव प्रलिप्तदिग्वधूमुखे मथान्तसिन्धुरस्फुरत्वगत्तरीयमेतुरे मनोविनोदमल्पुदं बिभर्तु भूतभर्तरी ॐ नमः शिवाय ॐ नमः शिवाय ॐ नमः शिवाय ॐ ॐ ॐ
Thank you so much, guys, for starting this program with a positive note.
We would like to call upon our dignitaries to join us on the dais to light the lamp. We request the chief guest, Dr. Raghavendra Prabhu, Deputy Registrar, MAHE Bangalore Campus, our guest of honor, Dr. T.R. Raju, Director Research, Shankara Academy of Vision, Bengaluru, our alumni, Dr. Kavina Ganapati, Assistant Professor, Jain DMTV University, our Dean, Dr. Jyoti Prasanna, MIRM, Bangalore, and our faculty and course coordinator, Dr. Shagufta Parveen, to join us on the stage.
we request our dignitaries to take back their seats.
We would now like to call upon Dr. Prasanna, Professor and Dean, MIRM, MAHE Bangalore Campus, to address the audience.
Welcome you all to MAHE Bengaluru. This is the campus where you will be shifting after 6 months. So as of now, we are in the Alalsalda campus, but soon you'll be part of a larger ecosystem that is MAHE Bangalore. To give you an introduction of what regenerative medicine is all about, you can see here, there's a microscope, there is gene editing, there is brain, there are different kind of human cells, there are exosomes, right? So what is this? We all know about cell biology, molecular biology, biochemistry, immunology. These are all the branches which have been there from ages, right? Then what is regenerative medicine about? Till a long time, before 2006, human biology was actually understood from the prism of what happens in animal model systems. A good example is all MTP studies. They were done in mouse models. So definitely the drugs which were developed in the mouse models were not as effective in the human system. Whatever knowledge we had on developmental biology, medicine was restricted from preclinical studies with animal models. But something changed in 2006. I don't know how many of you know about the Nobel Prize discovery by Yamanaka. How many of you know? Can you just? Yes, good. So in 2006, a seminal paper which was published in Nature by Yamanaka changed things, the way we look at human medicine. That was the time when he showed that an adult cell in the body, a simple fibroblast, which you can get from your skin, can be reprogrammed to a pluripotent cell. What does that mean? That means we have in our hand model systems where these pluripotent cells can be differentiated into different organotypes, right? Be it brain, be it cardiac, be it heart, be it lungs, be it liver, right? So this opened up a new area where we can look at human biology. We have model systems where we can do drug testing, we can understand human development better. And that's when the field of regenerative medicine emerged. Around that time, I was actually working in Manipal Hospital, the 9th floor of Manipal Hospital, where we were trying to develop corneal graft for burn victims, right? And we wanted to create a graft which can be suited onto the eye of the burnt victim. So the graft should be mimicking the tissue, right? So obviously it requires knowledge of, we needed people who had some knowledge on developmental biology, we needed people who had knowledge on immunology because you are going to transplant it into a human, right? And we also need to know what are the molecules or the chemical cues which have to be given to direct this graft to a mature stage. And that's where the problem arose, because either we got immunologists, cell biologists, or molecular biologists, but it required having a huge team, having expertise in all these domains. And that is around that time, Dr. Ramdas Pai, Padma Vibhushan, Dr. Ramdas Pai, visited our institute, and he asked, like, what are your problems? And we said that we are not getting manpower who could actually do this work, and that's why our work is getting delayed. And then he said, why don't we start a course? Why don't you develop a program which is interdisciplinary in nature, which encompasses all these fields, And we generate manpower which could cater to this growing demand because there are many degenerative diseases where no cure is available. If we have knowledge which integrates all these concepts, then we will have human resource which could actually cater to the need of the growing healthcare industry. And that is where, in the 9th floor of Manipal Hospital, we conceptualized 4 or 5 people, sat together under Dr. Tote's guidance. We developed the syllabus and the course framework for Manipal Institute of Regenerative Medicine. That was around the time in 2006. This is 2007, MIRM was incepted, and 2006 was the time when Yamanaka showed that, in fact, an adult stem cell can be reprogrammed, we can study development, we can model tissues probably and understand these things. So the timing was really perfect. The 2006, I was fortunate enough to attend the conference where when Dr. Yamanaka presented his work, everybody got up and gave a standard ovation. And this was before actually he was given the Nobel Prize. Okay? So the timing was perfect, and it was Dr. Ramdas Pai's vision to foresee that a field like this could actually emerge. So from 2007 onwards, from the 9th floor of Manipal Hospital, we shifted to Domlore, which was nearby, and then to the Alal Sandra campus. And now we have 3 programs, one on MSc in stem cells and regenerative medicine. Second is neurobiology, translational neurobiology. We also offer a diploma program on stem cell and regenerative biology because this was on demand, because there were a lot of clinician people who wanted to get and know in this get into this field, but they didn't want it. They could not. They were actually practicing doctors, and they could not actually be accommodated for a 2-year program. So that's where the diploma course started. And going with the interdisciplinary nature of our course, even our students come from varied backgrounds. We have students from pharmacy, we have dentists, we have biochemists, we have biophysics. We have a heterogeneous population, which makes teaching, learning very exciting for us. So 2 flagships of MIRM are basically academics and research. So what are MIRM strengths? We are very fortunate to be in the Bangalore biocluster, where most prominent national institutes are in and around us. So we work very closely in collaboration with NCBS, INSTEM, ISC, NIMHANS. One of our distinguished guests, Dr. Raju, was a NIMHANS professor, and he has mentored many students and faculty. Some of his students are faculty in this institution. So this gives us an edge because we collaborate with them. Some of these eminent faculty take guest lectures in our institute. So research is very, very integrated in our course curriculum. And we are away from the rote classroom teaching where you have books and you study, mark, and come and pass an exam. It's a 2-way process. It's an interacting learning process where teachers and faculties are themselves researchers. They have their own independent labs. They have their PhD students. So these are the people who come and teach. So obviously they will integrate the new cutting-edge knowledge in the field in their classroom teaching. So it will be a very interacting and exciting ride for all of you through all these 2 years. Our student-faculty ratio is, we have 10 faculty and we have 30 students. So it's like 3 students per faculty. And by the end, you will get a mentor list where 3 students would be allotted to 1 faculty, and they will take care of your personal, professional, your doubts, your problems. You can always go to these faculties and talk to them. And they are all very accommodative. I have asked Harish to circulate the list to all the new batch students. Our faculties are actually having their own projects. So they have project fellows, they have PhD students, they are all internationally actually recognized, they publish papers. So some of the MSc students actually get to work with them very closely during their elective period and during their project period. That is around 1 year of time. So if they are good and if they can grasp those concepts, and they get to publish very early on, right? During the MSc program itself, if they have a publication, then it gives them an edge when they're applying abroad for PhD programs, and they have an advantage in industry because they have learned all the skill sets to actually be ready for the industry. So we have our researchers do research on different fields like developmental biology, cancer biology, neurobiology, material science, cell biology, immunology. So you can clearly see that all these fields are coming together and integrating in MIRM. So there can, most of these faculty are collaborating within themselves and also with faculty in the Bangalore Biocluster. So it gives you an advantage over the core courses like a biochemistry or an immunology, because you can choose the problem and decide to integrate all these fields together to address the problem. Our faculty have attracted quite a bit of funding over the last few years. This is the funding statistics of just the last 5 years. We have 75 papers, we have 22 conference proceedings, presentations, we have 13 ongoing research projects, all extramurally funded. So each faculty have extramurally funded. So obviously during your project work, you won't face any hiccups with reagents, with other things. And if you are good, you can actually publish papers during that tenure of 1 year. Our faculty have international collaborations with Belgium, with University of Leuven, University of Newcastle, University of New South Wales, and they have national and international research collaborations. This proves to be advantageous for the students because they get placed very easily. Sometimes if they do a collaborative projects during their masters itself, then it's like a direct entry to these institutions. We have continuous skill developmental programs because definitely technology is not static. Every day things change, you know. With each Nobel Prize, you have opening up of new areas, and we have to catch up with it if we want to do well academically as well as in research. So we have almost quarterly skill developmental programs being organized in MIRM. So we had a workshop on immunotechniques on the National Immunology Day. So this is just the statistics. This is what I'm showing for the past 6 months. So you can understand in an year how many skill developmental programs would be actually done. So this keeps the students as well, the MSc students as well as PhD students adept and to keep pace with the new technologies which are being developed in this field. Our students have done extraordinarily well. You can see most groups. I mean, excuse me if I have left out a few. I wanted to make a single slide was not enough for it, but I have put most of the students who have been who have got awards both nationally and internationally in the past 6 months. This is just the data for the past 6 months. So you can clearly see that it's a very vibrating atmosphere in MIRM where all of us work close together with each other. We cherish each other's accomplishment and aim for the best. And that is the culture which we aim and which we have been building in MIRM from the past 10 to 15 years. So we have a lot of guest faculties which are invited from time to time. So some specific lectures, some specific topics are actually, if we don't have internal expertise, we would call upon eminent personalities and eminent scientists in our field to come and deliver those niche lectures. So the students have an advantage of talking to these people, interacting with these people, and probably even design their ideas for the future. Suppose somebody wants to go for a PhD and an eminent professor comes, if they like you and like your ideas, they directly take in to their research program. So it's ultimately up to the students how they would exploit the ambience, exploit the atmosphere at MIRM for their career development. Our alumni have done exceptionally well. One of our alumni, Dr. Kavina, is here. I'm very proud to say that she was third batch student, so that was 2009, and now she's here leading her own independent research group in Jain University. She has her own PhD student. This tells the kind of journey she had from MIRM to now. Our students have also been entrepreneurs. They have started their own companies. I didn't have his picture, otherwise Mr. Rajesh from 2010 batch has his own company now, has his own startup. There are people who have gone ahead to not only do their PhD, but they are doing postdoctorates. Dr. Shatrunjay Singh is actually an independent faculty in Yale. So our alumni have done really well, and most of our students have actually stuck to us. They are continuing their PhD program here. You will see Jeevan here. He's a part of our transport coordination committee. So you can clearly see, like they want to continue their journey from MSc and beyond. So the highlights of our courses are we provide not just rote learning. I'm telling again and again, we want to provide you an exciting interactive experience where emphasis would be more on practical training, and which is the course curriculum is research integrated, and mentoring. We provide all these faculty who are all independent PIs are going to mentor you and handhold you through this professional journey, both personally and professionally. And then we wish that we aim to make you confident individuals who are ready to face the world and become leaders in not just research, but also industry. Thanks a lot, and I would wish, on the behalf of faculty and staff, I would like to welcome all of you on this exciting 2 years journey, and we are all there, of course, from 9 to 6:37 and beyond. If there is an emergency, if you want to talk, toss out ideas, discuss anything under the earth, we have a very interactive atmosphere in MIRM. This is a place where you won't be scared to ask questions. In fact, you would be encouraged to ask questions. Thank you, and we and faculty are there to guide you through this process. Thank you.
Thank you, Dr. Jyoti, for addressing the audience. We would now request Dr. Jyoti to kindly be on the stage for some time. We would like to request Dr. Uttara Chakraborty, faculty and professor here at MIRM, to honor our dean.
Thank you, ma'am. So now let's invite our chief guest, Dr. Raghavendra Prabhu, Deputy Registrar, MAHE Bangalore Campus, to address the audience. Over to you, sir.
So good morning to all of you. So Professor Dr. Raju, Dr. Jyoti Prasanna, the faculty members, staff, my dear students, parents, a very good morning to all of you. It is my pleasure to be a part of this orientation program. So congratulations on taking this significant step forward in your academic and professional lives. So each one of you has achieved great heights to be here, and I commend your hard work. dedication, and passion that brought you to this moment. The pursuit of higher education is a testament to your commitment to excellence, and it is with great pride that we welcome you into our postgraduate community. The path of postgraduate studies will undoubtedly be challenging, but I assure you that it will be equally rewarding. Your commitment to learning and the pursuit of knowledge will be essential in this journey. Prepare yourself for late night research, heated debates, group projects, and moments of inspiration. Your critical thinking and problem solving skills will be honed, and your capacity to innovate will be expanded. Dear students, you're all embarking on a new journey, a journey that is bound to shape your course of your lives. At MIRM Bengaluru, we assure that your dreams of self-exploration, your aspirations to become independent and mature individuals, and your quest for knowledge find ways to materialize into reality. For the next 2 years, you will be surrounded by countless opportunities for leadership and personal growth. Remember that you are all not alone in this endeavor. As Dr. Jyoti Prasanna mentioned, our faculty members and staff are here to support you every step of the way. They are not just teachers, but mentors and guides who are dedicated to your success. So don't hesitate to seek their guidance, ask questions, and engage in thoughtful discussions with them. As PG students, you will have greater autonomy over your studies and research projects. This newfound freedom brings responsibility. Take ownership in your education, set ambitious goals, and be proactive in your pursuit of knowledge. Your time here is limited, so make the most of it. As Dr. Jyoti Prasanna already mentioned, by the beginning of next academic session, probably by December, January, so MRM will have its own campus or a place in this particular campus. So it will have a state-of-the-art infrastructure and research facility just adjacent to this building. So we call it as Academic Block 2. So the complete ground floor and first floor will be occupied by MIRM. So having been on this campus of this nature, where you will be along with the shoulders of the students of other disciplines, especially engineering, law, liberal arts, humanities and social sciences, commerce, management, art, design and technology, and many other disciplines. It will be an opportunity for you to have a great interdisciplinary interaction, both in terms of your learning, research, and also in terms of your future plans. It will shape your character into a holistic development of a student and as a human being. While academic excellence is crucial, it is equally important to strike a balance between your studies and personal life. Engage in extracurricular activities. We have plenty of facilities in our campus. We have outdoor sports facilities. The indoor sports complex is also getting ready. So probably within 2-3 months. So all the facilities will be ready definitely before you come to this campus. So the food court, the indoor sports complex, the outdoor sports facilities are already operational. So make maximum use of that. So as postgraduate students, you are positioned to make a significant impact on society. Your research, ideas and innovations can shape the world for the better. So embrace this responsibility with humility and the knowledge that your contribution can change lives. In conclusion, I welcome you all once again to this incredible chapter of your academic journey. Cherish every moment, seize every opportunity, and make the most of your time here. Remember, you are now a part of this wonderful academic community, and together we will strive for excellence in the pursuit of knowledge. I wish you all the best in your endeavors, and I look forward to witnessing your growth and achievements throughout your postgraduate studies. Thank you very much. Thank you for the opportunity.
Thank you, sir. So I now request Dr. Uttra Chakraborty, sir, to hand over a sapling as a token of gratitude to our chief guest. Thank you, sir, and thank you, ma'am. So up next, we have the guest of honor, Dr. T.R. Raju. So to introduce our guest right now, we would request Dr. Jyoti Prasanna, Professor and Dean, to come and tell a few words about our guest of honor.
It's a pleasure, sir, that you accepted our invitation on a very short notice and grace this occasion. Dr. Raju has been associated with MIRM from quite some time. He does come over whenever to deliver a guest talk. He came, if I remember, in 2016 to 18, where he was talking about adult neurogenesis. The concept of adult neurogenesis was still developing at that time, and all the students were very excited, and I can still remember the day. Dr. Raju is an MSc in physiology from JIPMER, University of Madras. He did his PhD from John Curtin School of Medical Research, Australian National University. He did his postdoctoral training at Harvard Medical School. Then from then on, he joined NIMHANS, and he has been one of the youngest scientists in NIMHANS to get professorship. That is what is mentioned in his CV. So that clearly tells his ambition and his research credibility. He has more than 250 research publications, all in reputed journals. His H index is 49, and he has attracted extramural funding more than 12 in NIMHANS. Forgive me, sir, in case I have missed something. He has been rated one amongst the top 5 neuroscientists in India. He has received the highest of high honors in neuroscience and physiology from Indian Academy of Neurosciences and APPI. One distinguished feature which puts him apart from the other scientists, which I have always cherished, is that he makes most of the complicated concepts in neurobiology very simple, interesting, with his wit, humor, and simplicity. Thanks for that, Dr. Raju. With this, I would welcome upon Dr. Raju to deliver his lecture.
It won't show movies. All these pre-preparations do make me nervous. Hopefully I won't be. Good morning to all of you. Thank you so much, Dr. Jyoti, for a very generous introduction. And I am delighted to be a part of this orientation program of a wonderful institute. I am deeply impressed about the achievements of this institute. I am sure it has very, very bright future also. So I was just wondering, normally a guest of honor will give a pep talk, which will be just of 5 minutes. But when I realized that, I'm slotted for half an hour, let me better stick to a science talk. Scientists are always comfortable with a science talk. So having said that, you are joining a wonderful translational science program. Why do we need translational science? Greatest discoveries in medicine have come about because of the relentless pursuit of science. And look at the state of medicine as of date. I know in neurological diseases, we just manage the diseases. We don't have a cure per se. Talk about epilepsy. We manage the diseases, no permanent cure. Stroke, we manage the disease. Parkinson's disease, we manage the disease only for a few years. After that, the poor patient goes through a lot of trauma. Alzheimer's disease, do we manage? Maybe very, very marginally. And we worked on a disease called amyotrophic lateral sclerosis motor neuron disease. It's also called motor neuron disease. Unfortunately, we can't even manage. Even if you look at psychiatric diseases, we just manage them. So why are we not finding any cure? Because we need to understand the biology of the disease, which we are still struggling to understand. So why translational research is important? So translational research or translational science transforms knowledge from basic science to the discovery of new drugs, new form of therapy, or biomarkers which we need for early diagnosis of the disease, for monitoring the disease, to understand the pathogenesis of this disease. So I'm going to tell our saga with translational research, hopefully within half an hour. So we thought we would work. Always as scientists, you want to take up a challenge. And which disease we looked at? This is amyotrophic lateral sclerosis. This is a very dreadful disease. I'll come to it. So we thought that by our efforts, retrospectively thinking, it was over a period of 3 decades. Can we make a small difference to the understanding of the pathogenesis of the disease? Can we develop a biomarker to diagnose this disease objectively? And also, with our discovery, can we come up with a process to discover new drugs for treating the disease? I will tell you what all we have achieved. So about this disease, it's a crippling disease, it's a devastating disease, it's a debilitating disease. The disease progresses relentlessly after the diagnosis. Within 2 to 4 years, the patient is gone. So they come with muscle weakness and fasciculation, twitching of the muscles, dysarthria, difficulty to speak, dysphagia, difficult to swallow. It is difficult for them to drink a glass of water too. And also, they end up with respiratory muscle paralysis. So, patients die within 2 to 4 years. And it gives a traumatic and shattering experience for caregivers. So, this is a massive transformation of an individual which can occur very, very fast. I had a movie to show, but it will take more time. So, not that the patient doesn't want to fight the disease. They fight the disease. They try to do anything and everything possible. But unfortunately, ultimately, the disease wins. Wouldn't you, as a scientist, want to do something to understand more about this disease? That is what we thought we would do. So, any scientific research starts with a hypothesis. We thought CSF, the cerebrospinal fluid, which bathes your nervous system, may contain a toxic factor which is detrimental to motor neurons. In this disease, motor neurons die, not sensory neurons, but motor neurons die. So it may have the patients may harbor a toxic factor which we need to isolate and characterize, prove that there is a toxic factor. So we got experimental samples from CSF, from ALS patients. Since I was part of NIMANS, more than 200 cases of ALS come to NIMANS every year. So we could get as much samples as possible. And we need to have control samples. So we got CSF samples from non-ALS patients, non-neurodegenerative, and non-infectious. So we have a patient sample, we have a disease control sample, and we need a control CSF without any, it is impossible. I can't go and tap you and get some CSF out of you. So the next possible thing was to get CSF from orthopedic patients. They don't have any neurological diseases, but when they give spinal anesthesia, they tap it and CSF comes out, and that was our control human CSF sample. What are the experimental models we used? In 1990, primary cultures was the only thing possible. I will never denigrate the primary cultures though. You can still learn a lot from primary cultures. From embryonic rat spinal cord, then we had a motor neuron cell line, NSC34 motor neuronal cell line, human embryonic stem cell derived motor neurons, and we also could of late obtain iPSC from ALS patients. These are our in vitro models. The in vivo models are newborn rats and adult rats. Newborn rats, intrathecally, we would inject the CSF samples and look at what's happening to the spinal cord. And adult rats, we injected CSF intracerebroventricular route. Okay. So what do we get? This is with the early work, primary cultures from rat embryonic spinal cord. On the left, if you look at motor neurons grown in the presence of normal ALS CSF, if we have a pointer, yeah, we do have a pointer. So you can see, doesn't work. It's okay. It doesn't matter, then you need to believe me, whatever I say. So on the left, you have a reasonably beautiful So if you look at the, can you hear me when I move around? Because I'm far away from mic. So you, I don't think, can you see the pointer there? So there are beautiful looking motor neurons. I have to praise my own neurons. This is 1991 in India, first time we are doing it, although I've done it before abroad. So these neurons are very good looking, fantastic processes. These are exposed to non-ALS CSF. On the other hand, the same cultures, if you expose to ALS CSF, look at the beating of neurites, the arrows, and cell body condenses. And there is massive vacuolation of cells. So non-ALS CSF does not do any damage to motor neurons, but ALS CSF causes beating of neurites, condensation of cell soma, and vacuolation of the cell. And if you want to look at it with immunofluorescence, this is apparently a lovely looking neuron. And we stained with an antibody against phosphorylated neurofilaments. And you could see, it will show. I think battery cell is weak. You can see a neuron. Okay. Now, here you can show. Even you can use the touchpad over here and show the pointer will be there. I'm 71. You should make things easier for me. Okay. Yeah. Yeah. Okay. So the neuron looks nice, but you see there are beaded neurites, indicating this neuron is undergoing degeneration in the presence of ALS-CSF. Also see the soma staining. See, phosphorylated neurofilament should not be present in the soma of a normal healthy neuron. If it is there, it indicates that the neuron undergoes degeneration. So we did it with primary cultures. And you can say, after all, you are showing it in rat neurons. Does it happen in human motor neurons? So what we did was, we could get from human embryonic stem cells, from JNC-ASR. So we used different differentiative markers, TGF, BMP inhibitors, retinoic acid, SHH agonists, and neurotrophic factors. So we could derive motor neurons from human embryonic stem cells. Now we are no longer dealing with rat neurons. So we have moved to human motor neurons, which are derived from human embryonic stem cells. So we used different markers. We used TAT, beta-3 tubulin, and this is the merged image. These are markers for motor neurons, and we managed to show that the motor neurons which we have derived from human embryonic stem cells express objective markers of motor neurons. The proof of pudding has to come from eating. In the case of motor neurons or any neuron, it is electrical activity. So we grew these neurons in multi-electrode arrays and look at their activity, their action potentials. Based on the analysis, this is a 64 array multi-electrode plate. So based on the firing, we found that 80% of our neurons are projection neurons. So these are projection neurons, means obviously it's motor neuron. Then when we expose these motor neurons, which are derived from human embryonic stem cells, they showed a beating of neurites and vacuolation, and the cell viability also decreased in the presence of ALS CSF. These are so I have to play here. This is ALS CSF. This is normal control, non-ALS CSF. So there was a decrease in the viability of motor neurons, which are derived from human embryonic stem cells, just like what we saw with rat motor neurons. And there was an increase in the production of lactate dehydrogenase, indicating that these neurons are undergoing necrosis. So again, the question we asked was, is it something limited to in vitro? Doesn't matter whether it's rat neurons or human neurons. It's just in vitro. Then I told you in the beginning that we had in vivo models also. Let me have a pause and have some water. Yeah. So we intrathecally injected the CSF into newborn rats and stained them for phosphorylated neurofilament epitope. So what you see on the left, non-ALS CSF, you can see the motor neurons are not stained. We are looking at the ventral horn. They are looking like empty spaces. This is going to be tough. No, okay. Look at empty spaces. So the neuronal soma were not stained with this antibody, indicating the neurons are not undergoing degeneration. On the other hand, you go to ALS CSF, the motor neuronal soma were stained with phosphorylated neurofilament antibody, indicating that these neurons are undergoing degeneration. There was no change in the dorsal horn neurons. And also look at here. The neurites or fibers look very healthy. Here it's completely disrupted following injection with ALS CSF. The discoverer is sitting here for this slide, Shobha. And Shobha found that when you intrathecally inject CSF into the rats, there are other changes also occurring. And she found the red sign. Okay. And she found, again, this is non-ALS, ALS, and expression of GLT1 glutamate transporter 1, that is green labeled, and the red is GFAP astrocytes. So this is non-ALS CSF. Come to ALS CSF. There was a down regulation of GLT, the green label. And there was a massive gliosis in the gray matter also. You can see the presence of astrocytes here, but not here. So ALS CSF injection caused down regulation of GLT1. Glutamate transporter is very, very important molecule, because after the synaptic transmission is over, glutamate should be taken up using glutamate transporter by astrocytes. But that's not happening here. So glutamate can hang around in the synaptic cleft for a long time. So that's detrimental to the postsynaptic neuron. So we found GLT1 downregulated, Western blot is also here, and there was an increased astrogliosis. In the gray matter also, we found astrogliosis. Then another important thing we observed, we grew the astrocytes in culture. In the non-ALS CSF, the astrocytes, large, epithelioid, they are labeled with GFP labeling. GFAP labeling, glial fibrillary acidic protein. And historically, I have been associated with this antibody. Amico Bignami and me first introduced this antibody in 1979 at Harvard. Yeah. So it selectively labels astrocytes. So this is in the non-ALS CSF, but you go to ALS CSF, they become process bearing. Completely process. There is a transformation in the morphology from epithelioid shape to process bearing. What does it indicate? Interesting story behind. The epithelioid astrocytes support neuronal survival, neurotrophic, whereas the process bearing astrocytes are neurotoxic. So ALS CSF transforms the neurotrophic astrocytes to neurotoxic astrocytes that we observe. Then what happens to the other glia, important glia? The microglia. In the control non-ALS CSF, they are ramified, arborized. And some people call them M2, but that is again being questioned. Some microglia specialists are here. This is in the normal, but when you expose them to ALS CSF, they become amoeboid and with a huge cell body. See, the amoeboid microglia again, toxic. So ALS CSF transforms microglia also from ramified to amoeboid. So quantitatively it is shown here with normal control, non-ALS CSF and ALS CSF. You can see a significant heaps of increase in amoeboid microglia following exposure to ALS CSF. And this is a movie, I don't know whether it will work. This is a problem, compatibility. So this is a nice movie. Can anybody? So you can see all this M2 type microglia on the left, normal control, ramified, and on exposure to ALS, they become amoeboid. These are dynamic pictures, movies. Otherwise, no. It won't work in a PC to Mac. Since I use both, I know the problem. So, but this movie would have shown you in a dynamic fashion how this M2 microglia, normal control, ramified lots of processes, whereas when you put ALS CSF to this culture or expose them to ALS CSF, they become massive cells, amoeboid. And this particular cell is so massive. It'll move from 5 o'clock position to 11 o'clock position. Beautifully, it's captured in the movie. And I leave it to your imagination, unfortunately. And we also found that these microglia on exposure to ALS CSF were highly motile, and they had a leading edge and a trailing edge. And they start secreting microvesicles. And you can call it with different terminology also. Anand, you call it what? Microvesicles, something, excretosomes or? Yes. Okay, it can, but the important point to note here is that on exposure to ALS CSF, they become huge, motile, and they start secreting these microvesicles. And the microvesicles can carry neurotoxic substance, so it can produce intercellular damage. So what would we find with all our experiments? there was a selective vulnerability of ventral horn motor neurons. The next thing I didn't show, but we observed damage to organelles, mitochondria, Golgi apparatus, endoplasmic reticulum, lysosomes. All organelles of the motor neurons are affected. And reduced expression of ion channels. For a neuron to function well, you need ion channels. Voltage gated sodium, voltage gated potassium channels were downregulated on exposure to ALS-CSF. There was an aberrant neurofilament phosphorylation, an abnormal cortical motor neuron firing, and the neurons underwent apoptotic and necrotic death. And we also looked at muscle. What's happening to the muscle? Because in ALS patients, muscles are damaged. The type 2 fibers undergo atrophy. There was a disruption and fragmentation of neuromuscular junction and loss of muscle power. So we looked at it morphologically and electrophysiologically, as well as the behavior, motor activity. And without movie, you won't appreciate this, but I can tell you that we injected this particular rat with ALS-CSF intracerebroventricular, and these are different control rats, and you put them in a rotor rod and increase the speed of the rotating drum. So those who have lost muscle power because of ALS-CSF injection, they will just simply fall down. Because you need a good muscle power to hold on to the rotating drum, which this guy unfortunately doesn't have. The movie would show it very elegantly. So, neuronal damage, what are the glial damage? To sum up, there was a morphological transformation of microglia and astrocytes. Microglia from ramified to huge amoeboid, astrocytes from epithelial to process bearing, and decreased glutamate transporter GLT1 and increased glutamate release, a double whammy for motor neurons, postsynaptic neurons. The glutamate is hanging around in the synaptic cleft for a long time because GLT1 double regulated, and more production of glutamate. Excitotoxicity for motor neurons. Enhanced oxidative stress parameters, ROS, NO, INOS increase, elevated pro-inflammatory molecules, PGE2, COX2, IL-6, TNF alpha, and decreased anti-inflammatory molecules, IL-10. And finally, reduced trophic factors. These are Golgi type 1 neurons like ganglion cells, retinal ganglion cells, pyramidal cells, mitral cells. They are critically dependent upon trophic factors. And there is a downregulation of trophic factors. So many insults to the motor neuron occur by injecting the ALS-CSF or by exposing the cultures to ALS-CSF. So what is in the toxic factor? Now, we went on talking for 15 years that this is happening, that is happening. Then we asked, what is there in it? Can you show it? We thought that we'll gamble. So we did a lot of proteomics experiments. Then while going in a taxi from Nimmans to Institute of Bioinformatics in Whitefield, who helped us with some of this work, I said, Anu was my student, I said, Anu, we'll bet on it. Because there is more secretion of this molecule we found in with our experiments, with them, proteomics, ELISA all, and this is chitotriosidase 1, and this is from the normal CSF is green, and ALS CSF is red. 10 to 12-fold more presence of chitotriosidase 1 in ALS CSF compared to normal CSF. And we looked at these chitotriosidase related proteins also, chitinase 3 like protein 2, and osteopontin. But nothing was as big as chitotriosidase 1. Is it something which we just observe in the lab, or is it a real thing? So we went and analyzed the presence of chitotriosidase in the CSF samples of ALS patients. The first one is normal CSF, non-ALS CSF, neurological control with other neurological diseases, and ALS CSF. Look at, there was a massive increase of chitotriosidase in the ALS CSF. And this is a protein level. There was something like 16-fold increase in the ALS CSF. Is it present in any other disease? Yes, it is. Multiple sclerosis, Alzheimer's. But only 2 to 3-fold, 1.5 to 2.5-fold. But here we are showing that 18 to 20-fold increase. And this is an enzyme. Even the enzyme activity was much, much more in ALS CSF compared to normal CSF or non-ALS CSF. So we think it is a reliable biomarker. The chitotriosidase 1 level can distinguish ALS patients with a sensitivity of 87% and specificity of 83.3%. And enzymatic activity of chitotriosidase has a sensitivity of 80.4% and a specificity of 80%. But if you combine both the protein level as well as the enzymatic activity, the predictive positive value was 97.78%. So it's a reasonably very good biomarker. And this work has been reproduced world over now. They agree that chitotriosidase 1 is an important biomarker for motor neuron disease. That makes you feel good. So, in terms of diagnosis also, it's a clinical diagnosis of ALS is very descriptive and subjective also. And this is able to distinguish from probable, possible ALS to definite ALS. Definite ALS has much more of chitotriosidase. Then the question comes, which cell in the spinal cord secretes this chitotriosidase? We found neurons don't, astroglia don't. Our next choice was microglia. Here the microglia are labeled with EBA1. In the top panel, it's normal control. And red is EBA1, microglia specific marker, and green is for chitotriosidase. In the normal control condition, there is no. But you expose the cultures to ALS, look, the microglia lights up with chitotriosidase. So there is a huge presence of chitotriosidase. The microglia are secreting more following exposure to chitotriosidase. So this is, again, unfortunately, the movie is not working. And chitotriosidase induces, microglia secretes the chitotriosidase. That, in turn, increases the microglial cell number also. So induces microglial proliferation. It's kind of a positive system sits in. The chitotriosidase is released and microglial proliferation and more chitotriosidase comes. So here again, on exposure to chitotriosidase, we managed to demonstrate that the huge cells come up and they start releasing these microvesicles. And apart from culture, can we demonstrate it in vivo also? We injected chit intrathecally into the rat, and this is normal control, and with the chitotriosidase and with ALS CSF. We found more of microglial proliferation with chitotriosidase compared to ALS CSF, whereas GFAP immunoreactivity was much more with ALS CSF compared to chitotriosidase. Then the next question we asked, okay, this microglia secretes chitotriosidase, and chitotriosidase in turn can make M2 cells to become M1 microglia, then they become neurotoxic. Can chitotriosidase have a direct action on motor neurons? So we intrathecally injected chitotriosidase, and this is normal control, and chitotriosidase at 500 picograms, and ALS CSF. This is chat label motor neurons, the normal control, very healthy. And you can see this chat labeling dramatically comes down with chitotriosidase as well as with ALSCA. So even much more in chitotriosidase when you inject it. So it can produce direct toxicity. So what is the proposed mechanism? A lot of guesswork here. This chitotriosidase protein, let's say it's secreted by microglia, and it can act through TGF beta receptors or toll-like receptor, and SMAD and MAPK pathways are stimulated, and there are changes in the transcription factors NF-kappa B, FOXOP, SP1 stat, and the microglia become activated. Then, ROS, INOS, IL-6, TNF-alpha, COX-2 are released. Then activation of astrocytes. Then in turn activation of more microglia, and the vicious cycle is set up. And that keeps on increasing this cytotoxic substances. And what can poor motor neuron do? When there is such a vicious cycle, when you keep on increasing the production of cytotoxic substances, and the poor motor, there are no trophic factor secretion also is reduced for them to defend, and it gives up. So we showed that chitotriosidase leads to glial activation and in ALS patients and neuroinflammation. So we believe that this disease, the motor neuron disease, is an augmented form of neuroinflammation. That is why the progress is so relentless compared to any other neurological diseases. So we are showing currently, so we showed the neuroinflammation with all our cell model, animal model, and we are showing in patients right now with PET scan. And you can use microglia-specific markers to see that actually such a neuroinflammation is occurring in human ALS patients also. And we need to work hard on elucidating the pathways for mechanisms of CHIT1 activation, chitotriosidase activation. And also we are in the process of creating organoids. That's a trendy thing, but I like it though. In 1979-80, we will say organ culture. That has become organoid now. And they are really fussy to make it even those days. And so we are creating an organoid culture with all iPSC derived motor neurons, microglia, and even astrocytes. So what, we went on to do some translational research. I told you 3 components for translational research: new drug, new therapy, come up with a biomarker, objective biomarker, which can explain to you the pathogenesis of the disease. And we have succeeded in the third one. We have developed a biomarker which tells you how the pathogenesis occurs because of neuroinflammation. Now the challenge is convert this biomolecule into a molecule of therapy. And we are hoping that we will enter into a collaboration with EU, India-EU joint venture. So hope to get it out, do at least something for the patients. And this has been, all the work has been done by all my students, postdocs, and my colleagues. I don't do much, I just talk. Some friends call me, I'm a used car salesman, I can sell anything. So I do that job, I don't do the hard work. So we are liberally funded. Currently, we had Center for Advanced Research from ICMR. Now we are running a Center for Advanced Research in Excellence. In India, we are never short of adjectives. So we can call ourselves Center for Advanced Research in Excellence. That's going on. And thank you so much. I want to wish you all the very best of luck for the new students. Enjoy yourself and study. You need to enjoy also. Thank you so much. Yeah, thank you. I'm sorry about the movies, that the movies are exciting.
We will try to get the movies to played. So, due to the diverse nature of the audience, I'm not sure how many of you could truly grasp what he spoke about. Perhaps
I hope
some of
all.
it,
I
I hope all. Perhaps some of it was jargon at this stage, but soon you will at least be able to appreciate what he's spoken about. And one important message that I hope you all at least take from this talk is the importance of control when you are trying to prove a hypothesis, the importance of such proper controls. So, to be able to receive such a talk from a stalwart like yourself, I would request the audience to capitalize on this opportunity. And if you have any questions, please ask. Can we play? Space bar.
So, if I don't know the answer, please feel free to ask questions. And I follow the American policy. If I don't know the answer, that's an excellent question. We'll look into it. Yeah. So we'll go to this is the first one. Thank you so much. You can work it. Otherwise, not to worry.
Excuse me, sir. Hi,
Yeah.
my name is Janvi,
Yeah.
and MSc first year, stem cell research. So my question was, while you looked into the cytotoxicity of CSF, was there any other paradigm that came like sideways and you went forward with that as well and that got rejected, and that's how you started working onto this?
That's a very interesting question. We tried with the serum initially, because serum would be easy to work with. And somehow, this toxicity was, we found it unique to CSF. Life would have been much easier if it was present. But, we did some initial.
Thank you, sir.
This is working, at least you can see this. The second from the right, my student is increasing the speed of the rotating drum. And the second one was injected with ALS CSF. He is trying to cope up with, but she increases the drum speed more. Poor thing, faster. That's the rat injected with ALS CSF. Because the muscle power was substantially reduced. As I showed you, there are changes in the neuromuscular junction, there are changes in the type 2 fast fibers, so it just falls. Thank you so much for not giving up. No, it's okay. Any other question? Yeah, this is M2. See, look at this. A cell with all process bearing. This is M2 microglia, normal condition. They have huge process. They look like neurons. That's the control. Now, go to the other one. And follow this giant cell moving from 5 o'clock position. So such a dramatic difference, with the same magnification. The other one was microvesicles, no? Yeah, you can, on exposure to phytotriasis, this cell starts producing microvesicles. You can see visually. Thank you.
If anyone has any questions, please feel free to ask.
Yeah.
Great talk. Thank you very much. I have a couple of questions. One is, are these CSF are collected from both sporadic as well familial? Is there any difference?
Very
between-
interesting question. It's not an American answer, but so in the cases we come across, the familial cases are very low in India. So all of them, nearly all are sporadic. Although they do harbor some mutations, but there is no family history. SOD1 mutation.
Yeah.
We don't.
Maybe a FUS is what which is
It
aggressive.
is sporadic.
Yes.
This is a very interesting question. I don't have the answer for that. But as I mentioned to you that, even in other diseases where Parkinson's, PD, and Alzheimer's disease, there is an increase in CHIT production. There is an inflammation. So CHIT expression is a mark of inflammation. But in motor neuron disease, this is aggressive neuroinflammation. Yeah, the proximal motor neurons, yeah. We have observed changes, but 90% focus has been on the spinal cord, yeah. Because there are, changes, intracerebral ventricular also if you inject, it's not only just the hind limbs, even the forelimbs are affected. And because our observations are over, histological observations are over a short period because the neurons undergo degeneration, but there is a reduction in food intake because the mobility is compromised slightly. Yes, see, we have been trying, we don't know much about the biology of this enzyme as such. In fact, the substrate, the known substrate for this enzyme is chitin, and which is, with fungal infection you get chitin, and it is produced. And it is increased in other systemic diseases also, but in neurological diseases, ALS, you get maximum. See, that's a good question. How do we suppress the activity of this? And that's the work, we are contemplating. Yeah, that's why I said, hopefully with the Indo-EU collaboration, how to convert this biomarker to a therapeutic agent. Huh?
Could there be others?
See, this is again a good question. I won't say excellent, that means an American. No, it's a good question because, we are just focusing from one angle. See, that's, you have to be honest in science in admitting. There could be other molecules involved. But what we found was a dramatic difference between this molecule in ALS compared to other neurological diseases.
Just one more question. The source of this enzyme, why is it elevated at a particular time? And what causes this elevation?
Yeah. So, we put ALS, CSF, and then, we start getting the increase in. But what actually triggers, something, which is a neuron-glia communication, something is hampered. Neurons always keep microglia under check. And if that check is compromised, they become active. Yeah.
Hi, sir. Very nice talk. Being an eminent neuroscientist, I would also like your take on other diseases like demyelinating disorders, especially GBS, you might have heard, which is
Guillain-Barré syndrome. In India, we call it Guillain-Barré syndrome. No, it's Guillain-Barré syndrome.
Yeah, so there is no treatment as such, as you said, we
Guillain-Barré
manage.
syndrome automatically in a patient gets better.
Yeah.
And plasmapheresis, another one, which we can give to treat them. But if you look at Alzheimer's disease, 99% of the clinical trials have failed. And whatever the new one which has come, the new drug, maybe it increases the longevity by maybe a few months or something. And probably you have to give it at the early stage. So the game is going to be detecting the disease. Pre-symptomatic ALS, if we could define and detect, maybe that's where we can give the treatment which may be of effective. But by the time patients come, 50% of neurons are already gone.
Thank you.
Any more questions from the audience, the students? None? All right. I hope at least in further talks, when you get used to all the technical aspects that you spoke about, you're able to push yourselves to ask questions, as you heard your to-be lecturers ask such thought-provoking questions, such basic questions about experimental design or how could the biology be different. So now I would like to call upon Dr. Uttara to honor our guest.
We'll do an action replay.
Okay, fellow researchers, we will break for tea. We will be back in the auditorium shortly. So your tea break is 10 minutes. After that, we will come back to just see how your course actually goes, the overview of your course, what subjects are you going to learn, how the syllabus is designed, etc. So see you all in 10 minutes. Thank you. We will wait for 2 more minutes for the other audience, parents, and students to assemble back. Then we will shortly resume. Thank you.
Can we request the PhD volunteers to check if everyone has assembled? Oh, that's
Welcome back, fellow researchers, parents, professors, my dear friends. So up next, what else do we have in store? We have one session on the overview of your course, how your course is going to go, your first semester, second, third, fourth, how many credits, mark distribution, etc. After that, we will have our chief librarian addressing us how to use the library facilities. And after our chief librarian addresses us, we have an an alumni, a special guest, to just share their experience and how MIRM was and is to them. So I would now request Dr. Shaguta Parveen, course coordinator, MIRM Bangalore, to come and deliver a short presentation on the overview of the course. Thank you.
Greetings to everybody present over here. I will give an introduction to the courses that are offered by MIRM and how we go about conducting these courses. We offer 3 postgraduate courses. The first one is Stem Cell Technology, MSc in Stem Cell Technology and Regenerative Biology. The second one is an MSc in Translational Neurosciences. And the third one is an Advanced Postgraduate Diploma in Stem Cell Technology and Regenerative Biology. I will start by describing the first program, which is the MSc Stem Cell Technology and Regenerative Biology program. This is the first program that was introduced by MIRM. It is a 2-year program, and the first year is teaching-based. We teach theory and practicals through a period of 2 semesters. The second year is purely project-oriented, in which the student will be conducting elective projects and dissertations. The entire program is divided into 4 semesters. The first semester, we teach fundamental topics of biomolecules, laboratory methodologies, architecture of stem cells, tissues, and organs, and embryonic development. Each of these subjects has associated practicals with it. On the slide, you can see there are credit numbers which are associated with each of these subjects. The student will be evaluated for a total of 100 marks at the end for each of these subjects. These 100 marks are divided as 30% internal assessment and 70% university, that is the end semester exam. We conduct our classes in a pre-designed schedule. We have 2 theories per day. We start at 9:30. We have each of these theories as 1.5 hours, and we have practicals in the afternoon session. What we do is we conduct subjects 1 and 2, or we call them modules 1 and 2, through the months of August and September. So we finish off 2 modules through these months, and we have associated practicals in the afternoon. Through the months of October and November, we conduct the other 2 modules, which is architecture of stem cells and embryonic development. The second semester consists of more stem cell specific subjects, intercellular communication in stem cell niches, biomaterials and tissue engineering, clinical application of stem cells, and non-clinical application of stem cells. Again, these are associated with practicals. They have specific credit numbers which are associated with them, and again, the student will be evaluated for a total of 100 marks as in the previous semester. The schedule remains the same, 2 theories and practicals through the months of January up to April. The second year, which begins with the 3rd semester, the student starts elective projects. The 3rd semester consists of a certain number of elective theory subjects, some elective practicals, and a mini project. The student will be evaluated for a total of 300 marks in the 3rd semester. The 4th semester is project work alone and dissertation. Again, the student will be evaluated for a total of 300 marks. These are some of the important dates for the MSc Stem Cell Technology and Regenerative Biology program. These dates will be circulated among the students. It gives dates on which important activities will be conducted, like dates of internal exams, internal practical exams, when the university exams are going to start, and when the 2nd semester is going to commence. The second program offered by MIRM is MSc in Translational Neurosciences. This is also a 2-year program. However, teaching is only for the 1st semester. The remaining 3 semesters include project work. The 1st semester has 4 modules or subjects: biomolecules, laboratory methodologies, fundamentals of neurosciences, and CNS development and disease. Each of these subjects is associated with its lab. The schedule is as follows. So the months through August and September, we will be conducting biomolecules and laboratory methodologies teaching. The students will be doing these two modules along with the MSc Stem Cell Technology and Regenerative Biology course. Modules 3 and 4, which are specific for the neuroscience program, will be conducted separately through the months of November, October, and November. Semester 2 will include an elective 1 project with theory, lab, and mini project. Semester 3 will have an elective 2 project, again with theory, lab, and mini project. And semester 4 is going to be project work and dissertation. The third program offered by MIRM is the postgraduate diploma in stem cell technology and regenerative biology. It is a 1-year program. It is not semester based, it is a yearly program. We offer 3 subjects: theory, laboratory techniques, basic stem cell biology, and application of stem cells. It includes 3 laboratories or practicals: lab techniques 1, lab techniques 2, and basic stem cell biology. There is also a mini project which is included in this course, which spans a period of 3 months. All the programs, they have all the markings of the programs. They have 2 components: an internal assessment component and an end semester exam component. I'm sorry about the spelling mistake over there. The internal assessment in turn has 2 parts. Each student will be assessed daily, and there will be sessional tests which will be conducted. These marks will be compiled, and they will account for 30% of the internal assessment marks that will be there in the final total. 70% of the marks come from the end semester exams. Practicals, 40% are going to be internal assessments, and 60% is going to be the end semester exam. All students must have 50% to get pass credit. That is, they have to pass the subject or the semester, they should have 50% marks. You have to score 50% separately in internal assessment and end semester exams. Attendance of 80% is mandatory, and you can carry over only 2 subjects. Year 1 has 8 subjects. Out of these 8 subjects, you can carry over only 2 subjects to the second year. If you have more than 2 subjects as carryovers, you are not allowed to proceed to the second semester and conduct your project. It is a pleasure to introduce the faculty of MIRM. First of all, I introduce Dr. Jyoti Prasanna. She has a PhD from the Indian Institute of Science, after which she joined the healthcare setup, the Stem Cell Research Group at Manipal Hospital, Bangalore, where she headed the corneal stem cell group. She was instrumental in setting up the immunobiology program at the center and was involved in ICMR-approved preclinical and clinical trials with bone marrow mesenchymal stem cells. She is a founding member of MIRM since its inception in 2007. Her lab focuses on exploring the immune system roles in stem cell fate decisions. She specifically researches stem cell regulation in chronic metabolic diseases. She studies innate immune system crosstalk in stem cell fate decisions, lineage reprogramming of stem cells to hepatocytes for drug toxicity testing, and damage signaling in injury and repair responses. She teaches a range of subjects: architecture of endodermal organs, development of gut and connective tissue, clinical and non-clinical application of stem cells, adult stem cells, and hematopoietic stem cells. Dr. Anujit also has a PhD from the Indian Institute of Science. He has postdocs from Leuven, Belgium, and during which he acquired in-depth knowledge about embryonic and induced pluripotent stem cells. He has been with MIRM since 2011. By far, Anujit is the most passionate researcher of MIRM, and his lab focuses on understanding how intracellular protein degradation dictates the neuroendocrine organ development and manifestation of related disorders using iPS model systems. He teaches formation of germ layer, formation of central and peripheral nervous systems, embryonic stem cells, iPSCs, and gene editing mechanisms. Dr. Anand has an MPhil and PhD from NIMHANS, Bangalore. He completed 3 postdocs from Magdeburg, Germany, Duke University, and the University of Tennessee. He has been associated with MIRM since 2011. His lab focuses on stem cell therapy, finding stem cell therapies for neurodegenerative disorders, and he teaches subjects of neurosciences, proteins, and animal models. He conceptualized and initiated the translational neuroscience system program, and he's also the program coordinator for the same. Dr. Manasa has a PhD from the Center for Nanotechnology and Advanced Biomaterials, Shastra University, Tanjavur. She worked as a postdoc in JNC ASR, Bangalore, and she has been with MIRM since 2017. She was instrumental in setting up the tissue engineering facility of MIRM, and her lab focuses on tissue engineering applications of peripheral nerve injuries, reproductive tissue disorders, and liver regeneration. She develops ECM substrates and bioinks for 3D bioprinting applications. She is also the PhD coordinator, and she teaches subjects including biomolecules, laboratory, etc., laboratory techniques, etc. Dr. Uttara has a PhD from the Bose Institute, Kolkata, and she did her postdoctoral research from Jawaharlal Nehru Center for Advanced Scientific Research. She joined FlowCell in JNC ASR as the facility in charge, after which she worked for 4 years as a senior research scientist in the divisional facilities of flow cytometry and confocal microscopy in the Indian Institute of Science. She joined MIRM in 2019. Her lab is called the Stem Cell Cytometry and Imaging Lab, and she focuses on exploring cellular and functional immunoheterogeneity in mesenchymal cells. She is developing an IFC ML-based tool for rapid detection of acute leukemia subtypes, and she is actively involved in education and outreach programs where she's teaching and training students with cytometry tools and technology. She teaches subjects of biomolecules, laboratory techniques, architecture of cells, tissues, and organs, and mesenchymal cell culture and characterization. Dr. Sangeeta has a PhD from the Indian Institute of Chemical Biology, Kolkata. She did postdocs from Leuven, Belgium, and Linköping University of Sweden. She has served as scientific staff in Linköping University and the Institute of Stem Cell and Regenerative Medicine in STEM. She has been with MIRM since 2019. She researches the very challenging field of tunneling nanotubules, and her lab focuses on spread of pathology in neurodegenerative diseases like Alzheimer's and Parkinson's, long-range intracellular communication in neurodegenerative diseases, cell-to-cell transfer of mitochondria, and its implications in cancer stem cells and chemoresistance. She teaches topics of biomolecules, laboratory techniques, architecture of cell tissue organs, muscle stem cells, hematopoietic stem cells, etc. She is an assistant professor, research. Dr. Lakshmi Narasimhan has a PhD, again from Shastra University, Tanjavur. He has postdocs from the Indian Institute of Science and has served as a research scientist in APRUS and Translational Health Science and Technology Institute, Faridabad. He joined MIRM in 2021. His lab focuses on creation of novel biomaterials, cancer theranostics, functional hybrid nanomaterials for biomedical applications, microfluidics, etc. He teaches subjects of biomolecule stem cells and tissue engineering. Dr. Meenal Francis has a PhD from the Manipal Academy of Higher Education and has worked in the field of pancreatic islet biology. She has more than 15 years of experience and is another faculty who has been associated with MIRM since its inception in 2007. Currently, her lab is focusing on pancreatic beta cell biology in relation to diabetes. She teaches subjects like molecular and cell biology, developmental biology, and stem cell biology. Dr. Urmi has a PhD from Albert Einstein College of Medicine. She has she did postdoctoral research at the Yale University and Memorial Sloan Kettering Cancer Center. She joined MIRM in 2022. She is the recipient of the Ramalinga Swamy Fellowship, which is a senior fellowship offered by Department of Biotechnology, Government of India. Her lab focuses on understanding fundamental mechanisms and pathophysiology of novel lysosomal amino acid storage homeostasis in response to extracellular environment. She teaches subjects of translational neurosciences, intercellular communication in stem cell niches, primordial tissue-specific stem cell biology, tissue remodeling and cancer, and concepts of polarity in cancer. Finally, I introduce myself. I have a PhD from MIRM MAHE. I have been associated with MIRM since 2008, and I have a teaching experience for more than 20 years. My lab focuses on modeling early human development and congenital malformations using pluripotent stem cells. Specifically, we concentrate on the bicuspid aortic valve disease associated with Turner syndrome and neural tube defects. I teach subjects like biomolecules, laboratory techniques, stem cell niches, etc. I am the academic coordinator of the stem cell technology and regenerative biology programs. I extend a hearty welcome to all the students who will be joining MIRM this year.
Thank you, ma'am, for giving an overview of the course. I hope people have starting to absorb the course. Take it from me, guys. Initially, it might sound a little theoretical for a week or two, depends on everyone's capacity. But once you gain momentum, you will actually understand what the course is all about. But until then, just hang in. So up next, we have 1 minute, guys. Okay, up next we have Dr. Ishapa Bandi, the Chief Librarian of Manipal Bangalore campus, who will be giving you a brief on how to use the library facilities. Thank you.
Yeah, good afternoon. I'm Dr. Ishappa. I'm taking care of all my Manipal Bangalore campus libraries. So MIRM, very soon they will be shifting to our campus, and we will be having a central library. But I'll be focusing on what digital content we have for you to access from anywhere. So because you are all doing intensive course activities, and you need a lot of content that is to current happenings in your field. So how these resources are helpful to all of you and how you can access that we'll be seeing here. So as I told, library is a hub of knowledge, and it will help you and support you in your teaching, your research work, and that role we will be playing for you in the next 2 years. So, and a lot of content, we have a subscription from main Manipal campus, and that we have access here from this campus also. So these are the where library will play a role in discovering new ideas and all that with the help of latest content. And this is I mean, you have an advantage of using not just medical resources, engineering, non-engineering, liberal arts, everything, because it's a multi courses are running in the campus, so you have access to all these resources. So we are using a good number of technologies, automation of library, and Turnitin software is a software where it will detect your submissions where all you have copied, pasted, and all that. So because you need to read and submit the your reports, your assignments, and all that. So this Turnitin is the software accessible to your faculty members, and this will help them to know from where all you have copied, pasted, and all that. So we have a Grammarly software where you can improve your writings and all that. And Open Athens is a software where you will use this to access resources from anywhere 24/7. I'll be discussing that. And we have a Coursera online package where you can, in addition to your course, you can have some of the courses from this Coursera. So this is a library portal. From here you will go to your library and you can access the resources. And these are the plenty of resources, online resources, that in the form of e-books, e-journals, articles you can access. So this is the list. And this is an open access platform where it's a one-time login. From here you can access all these resources. Full text access will be there. And this is the URL for that. And you need to select MAHE Bangalore campus. Then so your email, once you get your email, we will get that list, and we'll be integrating with this platform so that you can access the resources. So here this is Coursera, you can access. So there is a database called Scopus. Scopus, is anybody know Scopus? Yeah, Scopus is an indexing database which will help to know what are the publications has happened all over world in your field. You can make the search, you can see that what content has been uploaded and published in your area. So Scopus will help you to connect with the other researchers in the world, and it is one of the biggest indexing database. We have access to that. And another one is Elsevier Science Direct. It is again one of the biggest database which has science, engineering, all the content available in the form of articles, e-books, and we have the access for this. And a lot of medical content is available on Elsevier platform. So one more, Taylor and Francis, we have exclusive access for these journals, articles, and all that. And Taylor and Francis, all these e-books are downloadable. You can download the full text, you can read them, you can have your own collection. Like that, JSTOR, there are plenty of resources. And this is a Grammarly subscription we have for the MAHE Bangalore. You can register. Once you get your MAHE email ID, you can get register, and you can install this in your PCs, and you can it will help you to improve your writing assignments and all that, language improvements. This is the way. And Coursera, again, this is available for students, faculty. You can take some, for example, if you want to do some of the computer related courses and all that. So you can take the courses in addition to your the regular courses, so that it will help you to improve in your interested areas. So we have this daily news service. We will be extending this to our students also, where we cull out the important news from the newspaper and we circulate to all our users so that they will be updated regularly. So this was the last. Yeah, these are some rules and regulations. And this is our new central library coming up maybe in the 6-7 months time. The MIRM collection will also be part of this collection and this central library. And you will be getting the access to all other libraries like engineering, SMI, and management. All this content and all this will be available on the same building. So these are some of the activities library has conducted last year. So this year, current year also will have a lot of activities which will help you to know that, like a book exhibition, and book talks, database training sections. So all these we will be conducting for you all in the coming year. So these are some of the book talks for the faculty, students, and book exhibitions. So this is the quote. I will end with that. So please connect well with the library. That is our request, because I know you are very busy schedule, but spend some time in the library and read the latest publications and all that. So thank you. Welcome to MAHE Bengaluru. So this is a team as of now. So we'll be developing more in a bigger team for the in the coming days. Thank you.
Thank you so much, sir, for introducing all the facilities and tools. Thank you, sir, for introducing all the facilities and tools available for our students. I hope the students can benefit from all of them. So up next, we have Dr. Kavina Ganapathy, Assistant Professor, Jain Dimtwi University, Bangalore, to deliver the alumni talk.
Hi, I should be saying good afternoon now, because I was preparing for a good morning session. I'm going to keep it really short, because I think all of you are mostly hungry. I'm Kavina Ganapathy. I was right there 14 years ago. So I'm the 2009 batch. How many of you are just joined the course? Can you please? Okay. So how many of you could connect to the beautiful talk what Dr. T.R. Raju had given? Honest answer. Okay. For those who didn't understand, I was right there, because whenever our orientation happened, we were sitting there, right there, and these talks went above our head. Nothing. We understood nothing. Okay. But after a year, again, if Dr. T.R. Raju gives a presentation, I'm very sure those who have not lifted your hand will understand each and every points he has raised today, spoken, and you can understand it. I am the living example. You all can see me after 14 years here. And as an alumni of this institute, I take this privilege to thank all the professors who have been the backbone and who have shaped my future. I thank you from bottom of my heart, and for making me stand here today. And I've written a lot of points which I have to discuss, but after the talk, I realized that most of it is understood. And I say personally, whatever Dr. Jyoti ma'am has told in the morning is all true. It is all going to happen. Don't take that just because they are presenting something here, it might be promotional for the Manipal University. It is not like that. It is exactly like that, and it is very true. So all the success and achievements, what you see in the students, which you have seen in the morning, is all true. And I had 14 members in my batch. When I said I was just sitting there, it was 2009 when I entered. I had a mixed feeling. Mostly it is anxious, excited, and I was very nervous. And the talks, scientific talks, made me really nervous because I knew nothing. And the 14 members, I thought I could make friends because I was from St. Aloysius College, where the local groups were there, where I could talk to them, understand, we had a mutual understanding and all that. When I came here, 14 were from different part of the country. Different unique nature, different, the rate of understanding is different and all that. So that was also, I had to, but only one thing connected us, that is Manipal Institute of Regenerative Medicine, and the purpose of being here. And it was a small family, because I'm talking about Domblur campus. And when I see this, I feel like coming back and joining the course again. The library, I would personally ask her how. Okay, 8 p.m. We were 24/7 in the library, and I think our professor knew it. Most of the time when the attendance is called, the person is running out of the library to say, yes, I'm present. So it was very difficult for 14 of us because it was a new subject. And how these protein act, how the cellular level molecular events happen, and all this is covered. And it needs that the students are in the library. We used to carry our small blanket and the brush and sit there, I'm not kidding, because we wanted to pass this course. And it is not only the teachers who is going to help you, it is not the textbooks. It is the classmates, the seminar hours, and the JC journal club, what it has. Personal experience, I would like to share 2 experiences. So nowadays, you all have a lot of YouTube channels and animated videos where you can learn the cellular signaling and all that. You don't have to sit in the class and imagine, okay, that is going to bind to this and that. You have the animated videos. You're going to learn that by yourself, not attending classes. That's totally fine. But what I'm going to tell you today is, so it was what was very scary for me is the lab, because we used to do the experiments, and we used to understand the concept, the principles, procedure, methodology, everything we used to understand. It's the viva. Whenever we go in front of the professor, we know that, and I was the kid who used to get very nervous if I don't know the answer. So I'm all prepared. Okay, there were 2 experiments. One was that it was a kit method where I had to use solution A and B and get a compound, the result, coloration changes, and I knew the science behind it. I knew the structural difference behind it, and I knew each compound, what it does and all that, and I will not name the professor, I went to the professor very confidently that I can answer the viva. So they asked me the question, principle, procedure and everything. And then I get a question that solution A was, what is the storage temperature of solution A? I know the science behind how these react, but I never paid an attention to what is the storage temperature. It's a kit method, after all, That's one instance. Second is, we were doing some HLA typing, the karyotyping experiment. We were doing colchicine and all that. Very basic of where colchicine goes and binds, what happens, everything. It is understood, the structure, everything, calculations all done, went to the viva. All that is asked. The second question, the person asked me, what is the thickness of the slide you have used? And I was very disappointed. I came out of the viva, I was very disappointed because I had learned the whole night, of the concepts of science and everything. But when I understood the value of this is when I went to NCBS as a postdoc. You don't get guidance there, you have to do your own experiment. So I was setting up an experiment and I went to a confocal. I did an exam on confocal and then I took the experiment. But only one thing differed in my experiment is the thickness of the slide. Okay, I couldn't get the data right because the thickness of the slide mattered. And then I connected what our professors taught me about the storage temperatures and about the thickness of the slide. At that level, at the basic level, what you need is taught. It is called experiential learning, and I think that is what the MIRM does here. They will not tell you, none of the teachers will tell you, you have to take this path, this is how it is going to be. They are going to give you a clue, and if you are intelligent, you are going to take that and go further. And I feel that you're here already, and I want to congratulate you for taking that one step forward, for being very successful. And I don't call myself successful, I know that. I have a lot more to reach to go there, but I've reached till here, and I can always give that credit to my alma mater, that's Manipal Institute of Regenerative Medicine. Thank you, guys.
We request you back on stage. Thank you so much, ma'am. That was really motivational. So we request Dr. Uttara Chakraborty, Assistant Professor, MIRM MAHE Bangalore, to hand over the sapling as a token of gratitude.
So we have come a full circle now. 2019 on this day is when we started our masters, and now we are welcoming a new batch. And with this, we are at the end of the program. But a couple of important announcements before we go for lunch. First is that we are going to be handing out some papers at the desk as you exit the hall. You will have a list of students and faculty in charges. Students are free to interact with the faculty they are assigned to and ask questions if any. Lunch coupons have been provided at the starting, so please use that to avail your lunch. The first trip to the functional campus at MIRM would be at 1:15 p.m. for the parents and the new joinees and the volunteers who will be showing them in the campus. The second trip is at 2:15. Please assemble at the point in the main gate. For any queries, feel free to ask us or any of the PhD student coordinators. Thank you. I'm sorry. So, clearly the hunger has spoken. So, I would like to request Dr. Uttara to please come up on stage and deliver the vote of thanks.
Honorable Chief Guest, Dr. Raghavendra Prabhu, Guest of Honor today, Dr. T.R. Raju, Dean of Manipal Institute of Regenerative Medicine, Dr. Jyoti Prasanna, our respected guests, faculty, all office bearers of MIRM and the new Bangalore MAHE campus, and my dear students, good afternoon to you, one and all. I thank MIRM MAHE for giving me the opportunity to express my gratitude on this very special day with my vote of thanks. A very special thanks to our Deputy Registrar, Dr. Prabhu, for being with us in the first half of this event today, enhancing the warmth of this event by providing a beautiful venue to our Orientation Day program. On behalf of MIRM, I wish to express my heartfelt thanks to Dr. Raju for sharing your thoughts and efforts in pursuit of science with all of us. I'm sure they carried a great meaning to our students and to all those who have come to join us from today. MIRM can always boast of its students, and today we have just heard directly from an alumna. I'm very thankful to Dr. Kavina Ganapati, an MIRM alumna, who spent her formative years in our institute while completing her master's and doctoral research with us. I hope our students have been inspired enough by her words. I thank Dr. Jyoti for arranging this day for our new batch of students. It's not just an orientation day for them, but also a big get-together for the MIRM fraternity. And the full house participation that we see today is a huge success in itself. I would like to thank all the respected guests, the parents who have accompanied their wards here. I would like to thank the organizing team, teachers, and all our staff members. Special thanks to Mr. Harish and the office at MIRM for extending all help that was needed to organize this event. I would like to thank our transport team. Without you, covering this distance between the two campuses would have been difficult. Thank you very much once again. I would like to now thank the AV team here, especially Sumant and Subin, for all these special arrangements that you've extended to us, and by the arrangements expended to us by Mr. Gaurav Yadav, Director Admissions, and his entire team. It would be worth to mention Ms. Devyani, Divya Darshini, Mr. Prashant, Basavaraj, and Anmol for all these arrangements here today. Special thanks to the decorations team, of course, for making this event, this venue, so special for this event today. And finally, this day wouldn't have been possible without the wholehearted efforts of our students, and I want to thank them personally, individually, for their roles played today. Our MC for this event, Ms. Ayana Gupta and Alan Brito, PhD students of MRM. Thanks for this excellent coordination. Our star performers of the invocation program, the song and the dance, Ahana Das and Lawrence Soni, second year master students. Thanks for this lovely performance. Our PhD students, Govind, Vismaya, Aishwarya, Nasira, Jeevan, Rachana, Deepak. Thanks to all of you for your sincere efforts to pull up this program so neatly, non-haphazard, non-random today, organized perfectly well. Thanks to all of you again, and over to the MC once again. Thank you.
Thank you, ma'am, and apologies for the mishap earlier. So a little correction, since clearly my glucose level has gone down and my brain has stopped functioning. Instead of 1:15, we will meet at 2 for the first pickup. And the second pickup will be planned accordingly, so it's probably 2:30 or 2:45. Thank you so much. Have a wonderful day.